Okay, good morning. Welcome to class. Another physics class. I'm still your physics teacher, Mr. Moses. I hope you revised what we did in the last class. Before we go to today's topic, let's do a recap of what we did. In last class, we looked at heat, we looked at temperature, thermometer, where we said that heat is the average kinetic energy of the molecules of a body. And we went further to look at temperature. We said temperature is the measure of this average kinetic energy, and then the thermometer is used to measure temperature. We also said that the upper and lower fixed points are the readings on the thermometer when you measure steam and when you measure melted ice respectively. Now continuing with the thermometer, we're going to look at thermometric substances. This is the substance used in a thermometer whose properties varies with temperature. When you look at your thermometer, like the clinical thermometer for instance, there's this colored substance you see such that when temperature is high it goes up, and when temperature is low it comes down. That is a thermometric substance. It responds to temperature. It changes volume. It either expands or contracts with increase or decrease in temperature. Now that ability to expand and contract is referred to as the thermometric properties of the substance. It is the property of an object or substance that changes with temperature. Now we'll look at a few examples of thermometric substances. We have liquid mercury, which is popularly used in your liquid in glass thermometer. We have gas, we have the platinum wire, we have the thermocouple. So basically all these things have properties that respond to heat. Their thermometric properties are those that respond to heat. There is either an increase in resistance or an expansion in volume and all that. Now we'll go to types of thermometer. We have different types, but for the one that we'll be dealing with today in this topic is the gas thermometer, the resistance thermometer, and the thermoelectric thermometer. We'll be starting with the gas thermometer. The gas thermometer is a thermometer that deals with the increase in pressure of gas when there is an increase in temperature. That's a picture of the gas thermometer. That bulb, inside that bulb there is gas and it is placed in hot water. When there is an increase in the temperature of the water, the gas gains pressure. When the gas gains pressure, it goes up the tube. When it gains pressure, when the molecules of gas gain pressure, they push the walls of the container. So since the volume in this case is constant, there is supposed to be an increase in pressure and an increase in volume, but since it is constant, the volume is constant, it gains pressure and goes through the tube, pushing down the thread on one side and then causing the thread on the other side to go up. The other side is where the calibration is, so that is where you read the measurement. We said as the gas bulb is placed in hot liquid, temperature increases, causing the gas molecules to gain energy and increase in pressure, causing a forward push of the thread down the glass tube, giving rise to an equal upward push of the thread on the calibrated side of the glass. So it is the other side of the thread that you now read whatever measurement you want to read. That's how the gas thermometer works. Increase in temperature causes increase in pressure of gas, which pushes the thread to give you a measurement. Then we go to the resistance thermometer. The resistance thermometer deals with the increase in resistance of a metallic object when there is an increase in temperature. So when the temperature that it is used to measure increases, the resistance of the electrical resistance of the object increases. Now this increase is proportional to how much increase in temperature we have. The working principle says that the thermometer gives an increase in the electrical resistance of a metallic conductor with a corresponding rise in temperature. Hence, if there is a decrease in temperature, the resistance of the conductor decreases. Most times, this conductor is a platinum wire. It's majorly used, the platinum wire. So when there is increase in temperature, the resistance of the platinum wire increases, and of course you can read the resistance. Is the increase in resistance that they read. So in other words, this thermometer measures in ohms. Yes, because resistance is in ohms. This is the formula used to determine the resistance in the thermometer, where R0 is the lower fixed point, R100 is the upper fixed point, and RT is the one that we are looking for. Now the third thermometer I'll be looking at today is the thermoelectric thermometer. This one involves a thermocouple, where two metals are joined together, and then one junction of the metal is placed in a cold or melting ice, and the other junction is placed in hot water or steam, such that the difference between the cold junction and the hot junction will give rise to a current in the thermocouple. Okay, it is the difference between the cold and hot junction that determines the size of the current in the thermocouple, and that current is measured with a galvanometer. We said the working principle is that this thermometer involves the joining of two metals. I've said that, where one end of the junction is placed in steam and the other end in melting ice, which causes an electric current in the metal and can be measured with a galvanometer. So the difference in the coldness and hotness of the two junctions determines the size of the current, which is now read on the galvanometer. That will be the end of the class for today. Please go over it again and go over the questions in the module work. Thank you for watching. I'll be with you in the next class.